Okay, so this is the space panel now, and rather like the nanotech panel, every year we have the panel, and every year it all gets a bit less science fiction and a bit more factual. So I'm very pleased that of the representatives of the new space industry, the two we have here, Elon Musk and Faranetta, have actually done things. They've actually flown things, they've actually built things, and there's a lot of talk in the new space sector, and here are some people who've actually delivered things. Elon actually has to get away because he has to talk to NASA at 28 minutes past the hour. So we're going to start with Elon, and then we're going to hear from you, Chris, and then I hope we'll have a bit of a discussion with both of you before you have to rush off. So I'm sure many of you are familiar with Elon Musk and with Space Adventures, with SpaceX. But if perhaps you could give us the elevator pitch just to bring people who aren't familiar with where you're coming from up to speed.
Certainly. So I think we have some videos as well. If you're ready to play some of the videos, that might be a good way to start. Are the SpaceX videos ready?
Can we have the first video, please?
Well, while we're waiting for the video, I will describe SpaceX. So,
well, anyway, since we last saw you, you've flown a rocket.
Yes.
A little bit.
Yes. So,
here it is.
In fact, okay, so we're going to see, this is a video from our island. We launched from a small island in the middle of the Pacific. Just a close lift off. Let's switch to the next video. That's the Falcon 1 rocket that you see there.
So far, so good.
Yeah.
So the next clip.
The rocket business is a tough business.
There hasn't been a single rocket in the history of the business that flew the first time, has there?
Well, no new, well...
No new design, exactly.
Yeah.
So Space Shuttle.
Space Shuttle, arguably, yeah. That's true.
+3, +4, +5, +6, +7, +8, +9, +10.
We have liftoff confirmed. Copy. Good signal strength.
This is the LT on the countdown net. Falcon 1 is airborne at this time.
So that video is taken from a nearby island. This is the onboard video camera we're about to see.
Oh, cool.
Which is the round trip, actually. So this camera is on the second stage of the rocket, looking down, obviously. You may want to skip forward a few seconds.
There we go.
Yeah. That's the water deluge system. Some insulating foam still clinging to the rocket. Our own foam problems.
Okay, so we can see there's a bit of a problem there.
Actually, you can't. That's not really the nature of the problem. The problem occurred right here. The engine shut down. All right.
Right.
So So SpaceX. SpaceX, I founded approximately 4 years ago with the goal of revolutionizing access to space. It's a simple three-step plan, which is build launch vehicles to put satellites into low Earth orbit. Then step 2 is build a launch vehicle and spacecraft to provide humans to orbit services to the government and to private sector. And then step 3 would be to provide humans to another planet services to the private sector and the government. We've started with a small launch vehicle, the Falcon 1, and the idea behind Falcon 1 is to be able to test out all the technologies at a relatively smaller scale and prove that out well before we put any people on board.
And this rocket was carrying a satellite, and you're offering something like, is it $6 million?
Yeah, the Falcon 1 launch vehicle is a little over $6 million a launch. It's the lowest cost per flight to orbit of any rocket in the world, of any production rocket. And
So how much would you typically have paid for that?
if you went with, yeah, if you went with a domestic provider like Orbital Sciences, the cost for an equivalent rocket would be about 25 to 30 million. There are lower cost rockets available from Russia and Ukraine, which are refurbished ICBMs, but those are not really currently in production. They're taken off the shelf, and those are much more competitive. They're more in the $10 to $12 million range, but that's not a realistic price.
So the satellite, tell us what happened to the satellite on board that rocket.
Oh, okay, so when the rocket hit a dead reef about 200 feet away from the launch pad, the satellite got punted like a cannonball.
This is so cool.
It flew about 500 feet and landed back on the island, went through the roof of the machine shop, split a 2x6 wooden beam, and landed on the floor, more or less intact.
Satellites are designed to withstand taking off in a rocket. Can they withstand landing again like that?
Well, this was a pretty robust satellite, and it actually landed about 50 feet away from its shipping container. And so I think it was trying to get home one way or another. But at least we can say we never lost a satellite.
Right, so you changed. I hope I have a non-voodoo microphone now. Does that sound a bit less voodoo? That sounds a bit less voodoo. Okay, cool. So when are you going to fly the Falcon 1 again then? Later this year, or?
Yeah, the next scheduled flight is September, October. And one thing I should mention about the first flight is it was fundamentally a demo or beta flight.
Yeah.
It was not about the satellite. The satellite was there as an afterthought. It was a student-built satellite. And our customer, our beta customer, which is DARPA, Defense Advanced Research Projects Agency, what they paid for was a responsiveness launch demonstration. And in fact, they've bought another launch demonstration, which is in the September-October timeframe. And then we've got launches scheduled every 2 to 3 months thereafter.
Now, I see from your website that you have a Falcon 9, which is the big rocket launch slated for next year. Is that still planned?
Yeah, it's either end of next year or possibly early 2008.
Right.
The Falcon 9, unlike the Falcon 1, is a man-rated vehicle. It's designed with higher factors of safety, and
it's much bigger as well.
It's much bigger, yes.
So it's like 25 tons to orbit kind of stuff.
It's up to 25 tons to orbit, yes. In fact, we have another version on the drawing board that's not on the website that's capable of putting 50 tons to orbit. And that vehicle would be capable of, if you did 2 launches, of doing moon missions or Mars missions, manned moons or
So this is a
Mars
Saturn
missions.
V scale thing?
Not quite. It's about, the heavy version would be about a third the scale of a Saturn V, but it's more efficient.
Right.
So its capabilities proportionate to its size are better.
Well, the other big thing that's changed since last year, aside from the fact that you've flown something, is the, I want to hear from you how important you think it is that NASA has put up this contract called COTS, which does not stand for commercial off the shelf, but kind of does.
Yeah.
So what does it actually stand for? Commercial?
It's Commercial Orbital Transportation Services.
So basically they're saying, here's $500 million, can somebody build us something that can get to the space station, please? And,
right.
And they've now got 6 companies, and you're on the short list of 6 to
Right.
provide that service. They're going to make the decision in August. You're going to speak to them in about 13 minutes about this. Do you think that's a big shift? Is that kind of NASA saying, okay, there is something to this new space business after all?
Yeah, it's a huge shift. NASA essentially has put forward as you say, a $500 million program for a replacement to the space shuttle is what it amounts to. So SpaceX is in the short list to build the replacement to the space shuttle. I think we're the lead candidate.
And this would be a Falcon 9 based?
Yes.
So it would essentially be doing what the Soyuz is doing now?
Exactly. In fact, the Falcon 9 in its smallest version is a Soyuz class launch vehicle.
Right. And I suppose the question for those of you in this business is, historically, NASA and the incumbent builders of stuff have been the bad guys. And you were sort of, well, never mind about them, we'll go to Mars on our own and all this kind of stuff. And now here they are saying, well, actually, we'd like to buy some services from you. I mean, is there...
That is a big change.
Does that
absolutely.
require a philosophical change for you as well, that you
No.
actually have to collaborate with them? Or do you not care who buys your rockets as long as someone does?
I'm agnostic.
Okay.
We don't make value judgments about our customers. They can put a wheel of cheese into space.
So their money is as good as anyone else's, is the point.
Absolutely. If somebody comes to us and they want to put a wheel of cheese into space, we'll do that.
Okay, right. Or a ham sandwich. No, that
Absolutely.
was integrated into something else. So has this resulted? You've just had this conference earlier in the month, where all the new space guys get together in LA. And what was the mood like there? Was it a big change from last year? Has this changed the landscape?
I wasn't at the conference last year, but I can say that the mood was buoyant.
Right.
I think there's a lot of new investment coming into the space sector. You have guys like, obviously, Jeff Bezos, Paul Allen, John Carmack, who did Doom and Quake, and
It's hilarious. It's all these .com guys who are using the money.
Well, technology guys. I wouldn't say it's
technology
necessarily.
people. Okay.
Yeah.
So you've made your money in technology, and now this is
Right.
the new frontier. Okay. Well, I'd like to talk to Chris, and then maybe we can have a bit of a discussion about some things. So Chris, your company is Space Adventures, and you are the go-to guy if you actually want to go into space now. And you've got your $20 million. Is that the price? At the
Yes.
moment? Yeah. So you've sent 3 people to the space station already.
That's correct.
And you've got a queue of others coming.
3.
And you also do Vomit Comet flights, don't you? And,
Well, we don't like to call it that.
Okay,
but,
sorry.
The reason they call it the vomit comet is they do about 60 parabolas.
Right, so they
And
die
you start,
for the parabola.
Right, you
and
start feeling sick after about 15, and that's when
Okay, that's
we
enough.
stop.
That's enough for me. And you also do MiG flights to the edge of space and
That's
this sort of thing.
correct,
Now, you're starting to get into the business of actually. Well, you're not building any spacecraft, are you? But you have
We outsource our space program.
and you have a Russian firm that designed the Buran Russian shuttle, or the people who did that. Tell us about that, because you actually have a.
Well, we're using the Masishev Design Bureau, which designed the airframe for the Buran program.
So they're going to
But
design.
really, we're using the whole Russian space program.
Right.
Because there's a whole cadre of subcontractors that will be involved.
So this vehicle, the Explorer,
Right.
what sort of thing will it let you do?
Well, it's a suborbital vehicle. It'll go up above 100 kilometers, 62 miles, and it's reusable. It's a reusable rocket plane carried by, it's very similar to Spaceship One. And I
Right.
should add that we had that design before Bert's design.
Right.
But ours is on top. Bert's is a drop.
And when do you hope to be able to actually start flying these things?
2008, 2009.
So basically, in the next 3 to 5 years, we're going to see competition. We're not just going to see.
For suborbital.
Yeah, we're going to see
But I
competition.
mean, we have an operational orbital program right now, and that's what I work on. And we're actually developing a Circumlunar program where we use the Soyuz spacecraft to go to the International Space Station. And actually, we have a clip
Oh, you've got a clip as well.
of
Let's
the
see that.
scenario. But the idea is that the Soyuz, few people know that the Soyuz was originally built to go to the moon. And this is sort of a thing that was forgotten. And we came up with the idea for the Circumlunar mission because in the unlikely event that the space station isn't available, we could still use the Soyuz to go somewhere. And so we began developing on this Circumlunar mission. And we have just
Now, how would that work? Because there are already flights going backwards and forwards to the space station.
Can
with
we cue
people on
that
them.
video?
Oh, can we see the video, please? And we can just talk
And,
over it.
well-
But I mean, the point is that those flights are running already, and there are like empty seats that you're putting people in effect.
Well,
And this is-
for the
no one's going
space
to the moon.
station, okay, so this is a Soyuz FG launch vehicle. This is a standard launch vehicle in operation right now. I guess the beauty of this mission is that we're using a lot of existing technology. And the nice thing about the Soyuz launcher is that it has a launch escape system. So if anything goes wrong with the rocket, you can get the crew off, and they've actually had to use it on several occasions. So this is a launch escape system just being jettisoned, fairing. And here's the Soyuz spacecraft. It's solar powered, solar battery powered. And so essentially it's deployed. This is a modified vehicle. We would have to make some modifications to this vehicle in order for it to do the lunar mission. We'd have to beef up the life support system. We'd have to thicken the heat shield on it so it would be able to survive the re-entry coming back from the moon. You come back faster. You come back to about 24,000 miles per hour. So first phase of the mission would be to go to the space station. You'd spend about 16 days there with the crew. And then an upper stage, another stage is launched on another launch vehicle. And we're probably going to use a launcher called the Proton. Now this upper stage, it's very interesting. It was originally developed to carry manned crews to the moon. And the Russians took that from their lunar program when they canceled it, and they used it. They're now using it for commercial launches of communication satellites. So that upper stage is essentially put into the same orbit as the space station. The crew undock with their Soyuz and then would rendezvous and dock with the upper stage, which essentially would be trailing behind the space station. And I apologize for the sort of low-grade CGI here, and the reason for that is that this is a mathematical model of the actual ballistics of the mission, and the animation is kind of an afterthought. We were just interested in the orbital mechanics of this. And so the Soyuz docks to the upper stage fires and puts it into a highly elliptical orbit, which would then orbit the Soyuz spacecraft around the illuminated far side of the moon. And we would get within about 60 miles of the lunar surface. And it's about 2.5 days there and then 2.5 days back. And another one of the beauties of this mission is that we don't have to bear the expense of man-rating that big rocket to carry a crew on it. It's launched unmanned. And so we don't really have to do anything new to the rocket to make it safer. The rendezvous with the upper stage takes place in space. And so we save a lot of money there. And this is a $200 million with development and a test flight. This is an unmanned test flight. This is a $200 million mission. $100 million a seat. There's 2 seats available. Come and see me.
So the price tag is
after the
$100
session.
million there for anyone.
Yeah, come and see me after the session.
Checkbooks out, everyone. Okay, so that makes the 20 million to the you piggyback this on the back of this, and you get the free holiday on the space station thrown in there as well.
That's right. So. And so if anything happens to the upper stage, let's say the launch is delayed or there's a problem with the stage, you still get to go to the space station.
Right. That's great.
A little bit of insurance policy.
Elon's going to have to go in a sec. I just wanted to ask, because I'm not going to get the chance to ask you right at the end, but where do you see, obviously the next year you hope to win this contract and you hope to fly rockets. Where do you see your company in 3 to 5 years' time?
Well, I hope that we're the primary mechanism of getting people to orbit in the world. I think that's a realistic possibility. So that's where we want to be in 3 to 5 years. And frankly, by 2020, I'd like to see us take somebody to another planet.
And do you feel that the space policy is sort of up for grabs at the moment? I mean, no one seems to be very happy with the status quo. Everyone seems to think it's pretty stupid. Do you think there's a chance to completely start over and to have private enterprise as a big component of it?
Well, I think the only way that we're going to become a multi-planet species is through private enterprise. It's certainly not going to be through the government. The governments are terrible at cost optimization, I think really to the point at which becoming a multiplanetary species can happen, I think the point at which it becomes an exothermic reaction is if you can reduce the cost of moving to Mars, which is I think the only realistic possibility, to somewhere on the order of the cost of the price of a median house in California. Now,
so that's one analogy.
The price is growing, so I think that target is getting easier to achieve.
So every year it gets closer. You just stay where you are. No, my favorite example of this is if you look at the missions to Antarctica 100 years ago, the privately funded ones were much cheaper and lost far fewer people than the government-funded ones, which tended to go wrong. So there's a number of interesting analogies here. But okay, well that's great. Going back to you, Chris, what do you think about the current state of play in the industry? I mean, obviously the
NASA seems to be changing its position. Does that affect you, or does that just mean you have more stuff to sell people?
What really affects us, and this also affects Elon, is technology transfer barriers. The U.S. government seems to think that it has this proprietary space technology and it doesn't want it to proliferate around the world. Meanwhile, India has a very vibrant space program. They're building satellites. They launch satellites to geostationary orbit. China has a manned space program and a very vibrant communication satellite program. And so this technology is pretty much already proliferated. So it's very frustrating that to a certain degree we have to be very careful that we don't transfer any technology to the Russians. And really the only thing that they can learn from me is what not to do. You know, and we learn all kinds of stuff about operations from them, and it's just been very beneficial. But for Elon, it's a huge barrier, and you know it's.
Yeah, I wouldn't say it's a huge barrier. It's a pain in the butt.
Yeah.
But it is. I mean, our technology is 100% American, so there's no technology issues there. It's just that if we have a non-U.S. customer, it takes us 6 months to get a State Department permit to talk to them on and integrate their satellite. You know, and I think the biggest single issue is that we can't hire people who do not have a green card or not a U.S. citizen. So I couldn't have hired myself 5 years ago. It's ridiculous.
So that's the biggest single regulatory problem you face. I mean, you have all these other, you have the fight going on over Vandenberg and so on. But
well, we have a titanic struggle underway with Boeing and Lockheed.
About the right to use the spaceport at Vandenberg.
Oh no, that's minor.
Sorry,
we're trying to unseat them as the primary provider of launch services to the Defense Department.
Right. One of the things they're doing is playing dirty on these sorts of little things.
That's our opinion, yeah.
But you hope to launch from Vandenberg next year, right? So.
Actually, probably 2008. All of our launches through 2008 are going to be from our small tropical island in the middle of the Pacific. I feel as though I should have a white cat or something.
Yes,
I say that.
It is unbelievable, isn't it? But the thing is, every year you come back and there's more evidence and there's more going on, and it's less fictitious. Do you regard this $500 million contract as a prize, by the way? I mean, it's kind of.
Well, it's not a prize in the sense that it's all awarded at the end, only after you've achieved everything. It is awarded at milestone points.
Right.
So it is.
But it incentivizes the industry in the same sort of way.
Yes, it's not a cost-plus contract like the standard development contract. In fact, there's really two contracts going on. One is the Crew Exploration Vehicle contract, which is what NASA is developing to return to the moon. That is about a $15 to $20 billion contract.
Right.
Then there's the little itty-bitty contract, which is the $500 million COTS program.
Okay.
Although it's possible that the COTS program may ultimately trump the Crew Exploration Vehicle program.
Because you might get your foot in the door and you can then start to do other things.
Yeah, possibly, yeah.
Okay. No, it's past. I'm very aware that you need to call someone. So.
Yeah, and I need to depart. If anyone has any questions, I'm happy to answer them in the breakout session
exactly.
later.
We've got 3 minutes now, so if anyone would like to come and ask Chris anything, he's going to stay up here. But
all right.
Go. Make your phone call. Thank you. Go ahead.
Is on? Okay. 2 questions. One, what are your plans on the Circumlunar project for dealing with solar flares and killing the crew while you can't get back any faster than Newton's laws? What was the problem during Apollo? They just were lucky, basically. And then the second question is, who do you think is actually going to land on the moon next? The U.S., the Chinese, or private industry?
Well, I'll answer the second question first. It'll be Space Adventures. And regarding solar flares, NASA, they weren't lucky. They actually developed the science of solar flare forecasting, and there were space probes in orbit. And there is a whole, essentially, fleet of space probes right now that monitor the sun. And there's a hardened section in the Soyuz, which can be used as a radiation shield, and the reentry capsule is fairly thick. They're actually testing radiation shielding, plastic radiation shielding on the space station. And so any thick material, ideal material would be, let's say, some form of plastic. Water is a good radiation insulator. So I think we have the problem well under control as
This
far
moon
as solar
landing
flares.
you have planned, then, how
Yeah.
does that work? I mean, do you have a...
Well, we've identified another existing launch vehicle. The lander is essentially under development, and we believe that we can go back to the moon for under $2 billion.
That's an even bigger price tag, but how many people would you imagine taking?
It would be, you could get 2 people back. It would be similar to Apollo-type mission. You can get
Is
2
there,
people.
I mean, clearly there's demand of at least 10 people or so for the space station round trips, but the number of people who have the kind of money you're talking about for these other things must be even smaller. Is there, are there even 2 people in the world who want to do that?
We developed the market for Orbital, and we have at least a dozen people in line for that, and we get more credible inquiries every day. We've identified about 1,500 people worldwide that are financially qualified to do a lunar mission. And we have some solid leads
That must
there.
help you that a lot of them made their money in the tech industry, so they're kind of
But,
naturally inclined to want to do this kind of stuff.
Think about, yeah, it has. And there are governments that are also interested, and we don't necessarily have to use a private individual. But go during a break, go out here and look at the Pacific Ocean, and the components for most of your computers are made on the other side of the Pacific Ocean. And at one time, that was crossing that ocean was probably a lot harder than maybe sending a crew to Mars. And the moon is only 250,000 miles away, and it's this huge, untapped piece of real estate. And we have a few ideas of what it could be used for, but I won't even pretend to try and justify it. I mean, the future will prove out the moon's utility.
Okay, well, I think we'll leave it there. Thank you very much indeed.
Thanks.